Welcome to the Raw Coding YouTube channel. My name is Anton, and this is the second part video where we learn how to serve dynamic images using ASP.NET Core with the help of a library called ImageSharp. In the previous video, we saw how easy it is to use it out of the box, so pretty much the most of the video was integrating it with Google Cloud. In this video, we're going to be continuing the integration. However, we're going to be focusing on the caching. As always, don't forget, if you're enjoying the video, leave a like and subscribe. If you have any questions, leave them in the comment section. I did most of the work preparing this video on my live stream. The link to my Twitch is in the description. I have a C# course that is out. If you would like to know C# as I do it, I highly recommend you check it out. With that, let's go ahead and get started. We're going to continue from the same project. Cloud storage is basically a copy of the previous project. I just left it there. So for those of you who are supporting me on Patreon, that is where you find that implementation. Cloud cache is basically a continuation of that. The program CS just has this sort of setup. We then have the GCP image provider, which looks like this in its entirety, and then the GCP image resolver. Pause the clips here to check out what's going on. In the previous video, as I was saying, there wasn't much documentation, so what I had to do is actually take a look at the source code and see how they have implemented their own unique providers. For the image provider, we had to implement the ImageProvider interface. For the cache, we have to implement the ImageCache interface. Let's come back over here. We're going to create our public GCP image cache, implement the ImageCache, give this a body. Don't forget to say that this is a class, implement the missing members, and then there's going to be get async and set async. Remove the H over here as that's not necessary. For the two methods over here, hopefully it's not a secret. The process is going to go as follows. We're not going to have anything in the cache. We want to render an image. We grab the image, we configure it to be to a specific size based on the query parameters, and then we display it as well as set it in the cache. The next time around the call comes in, we check the cache, we find something in there, and we display it. What can happen in addition is that either the image gets updated or the cache gets expired. In that case, the cache will be regenerated and the image will be reserved. The logic for getting and storing will be shared with the provider over here. So let's actually grab the constructor over here. We will place it here, and really all we are reusing is the storage client. Let's leave the semicolon. First of all, we will deal with the set async. In the client, we will have an upload object async. And here we can specify the bucket name, the object name, content type, source, and upload options. One thing that is being passed over here is metadata. This is information about when the original object started to exist, when the cache object is starting to exist, and is basically what type of content are we storing, etc. This here is very important for consistent and reliable cache busting. Okay, so let's go to upload object async. We're going to use the same bucket, so jumping over here, I'm going to grab the bucket name, coming back over here, object name, we can just use key. We can use a cache prefix, so for example something like this, and plus semicolon on the end. We then also want the content type. Metadata will generally contain stuff like this, so content type, and actually if we have bucket name, object name, content type, then comes the stream. So we supply the stream, and there we go. Wait for this. Object should come on the other end. When I generally write my methods like these, which have many parameters, I like to spread them out each on their own individual lines. Once we have the object, we can go to the metadata, and because metadata is generally a key value store, you already have a convenience method like toDictionary on this image cache metadata. Go ahead and store that on the metadata, and then with the client, we can update an object, and then we just pass the object and actually call async here and await. The update object async method over here just sets the metadata. There is no way to set the metadata using upload object async. Unfortunately, I don't know why it is like that, but that's just the way that it is. For their other implementations, if we take a look at the set async method right over here, you get the blob where you want to store it, and you can actually pass your metadata as you're uploading, and this is for Azure, right? So depending on what provider you're working on, maybe this is going to be possible, but maybe not. Here I'm having to make two calls. First the uploading call and then the setting metadata call. Then for the image cache resolver, we want something that returns this interface, and funnily enough, it has an openReadAsync method, which is the same as this method. So this is just to resolve an image once you actually have it. So I'll just whack this interface on here and add this additional method of getMetadataAsync, which belongs to the ImageCacheResolver. Additionally, what I can do is I can take the ImageResolver and just make sure that this getMetadataAsync is specific or explicit implementation of this interface. With the cache, we are going to have an object which already should have the metadata. So object, metadata, and this will really work the other way as well. So this should evaluate the task from result. You will have the image cache metadata, and you can say use this static method from dictionary, grab it, place the metadata over here, and everything should work as expected. Let's clean that up. And then openReadAsync, we already have it. So yeah, that should just work the same. All we have to do is just create this GCP image resolver inside this getAsync. So return GCP image resolver, we will have to pass the client, and then we're also going to have this object resolution that we had before. So coming back to GCP image provider, we will have this get object async. So grab this, place this over here before we create the resolver, make this method asynchronous. The match over here, we're just going to make sure that we're using the same cache key that we're supplying in the setAsync. Place this over here. Make sure that we say that this is a new GCP image resolver, semicolon on the end, and then also supply the object, and this should be it. So we've done all that. Let's place a breakpoint over here. This is in the GCP image cache. We're going to duplicate this line and we're going to call set cache, supply the implementation over here, get rid of the rest. We're then going to go to the GCP image resolver. We're going to place a breakpoint on getAsync over here. And sorry, this is the provider. We're also going to go to the resolver. We're going to go to the openReadAsync. We're going to place a breakpoint over here. And then we will also place a breakpoint on these two things just to understand the flow of the application. I'm then going to right click on here, debug. With that now running, we have image.jpg over here. Do understand, let me just skip through these two. I'll remove this breakpoint in the middleware. Program CS, and we are clearing the previous providers. So right over here, we are going to go to image/image, and then I'll set width to something like 300, and the image should be .jpg. So first we hit the provider. This means we're checking the original location. We're checking the original location. We're then getting the metadata about the original location, right? So this is the image resolver. We're then attempting to get something from the cache, and this is actually going to explode. There is actually no good way to check if an object exists or not. So this is going to throw an exception, and if you want to signify that something is not present or isn't in the cache, you just basically return a null, which is what we're going to do in this situation. So let's go ahead and restart the debugger. Close this, give this a refresh. So again, we check the original image and get its metadata. We then check the cache. This should return null. So because it returned null, this should just go ahead and read the original image. The way that we can check if it's the original image here, we can check this object that's on here, and the image is image.jpg right here. And it's coming from the bucket. It's not coming from the file source over here. Pulling down the debugger, let's play through this. Coming back, you can see it's still processing a little bit because it's doing the conversion. And now the setAsync method is called, and we are going to store this processed image in the bucket, right? So this image right here, if I come back to the bucket, I'll give this a refresh. There should be a cache folder over here with the image, right? So this image is 18 kilobytes compared to the previous image, which is 3.6 megabytes, okay? Now, because we have the cache, if I refresh this page, again, we go to the original source, and the reason we're going to the original source is to make sure that that image is not updated. If that image is updated, we want to bust the cache. So the original source is always going to be checked. So whenever you're implementing this logic, make sure that you're not always just downloading the thing. Get the metadata first, which is going to be a lot less than downloading a megabyte of data, all right? So we again download the origin, we check its metadata, and then we check the cache. This time we find this object, and then we get the metadata for this cache as well. Internally, it's gonna do the comparison, and once it does the comparison, it's going to figure out has the object expired or not. If it hasn't expired, then all good. However, how come open read didn't trigger? We fetched the metadata for the two objects, but neither of them have been read, and we still got the image in the browser. Well, there is caching in the browser that ImageSharp is controlling. So again, let me go ahead and refresh this. We're going to step through all of these breakpoints. Again, open read is not going to be triggered. The document is going to be served, and it is because it is controlling all of these cache headers like last modifier and cache control with the max age, and this image is indeed being automatically resolved by the browser's caching. If I do a hard refresh and give a step through, we get the cache metadata, and because it's a hard refresh on the browser, now we're loading the cached image. Again, if we go down here, if we take a look at the ID of the thing we're loading, we are indeed loading from the cache, okay? And personally, I'm not doing any heavy lifting here. What's happening is ImageSharp is handling all the caching configuration and commands to the browser automatically. All I did was say, this is where the original image is, this is where you should be storing the cached image, and I also make sure I persist this metadata between calls. The rest is handled by ImageSharp. Let's take this menu. I'm gonna mute all of the breakpoints so we can actually see how fast it is caching from the browser, loading the image from the cache, right? So if I refresh, you can still feel it a little bit, 202 milliseconds. This is also because the server is, where I am located on my local computer, not in the cloud next to the bucket, where the communication speed is going to be a lot faster than over the crappy copper wire that I have here, right? So that's the caching situation. Let's go ahead and stop the debugger. I'm gonna collapse this down. Let's remove the breakpoints. And the next thing that we want to take a look at is, what if you have the image locally, but you want to cache in the cloud, right? So you have this image and you're just gonna have tons and tons of variations of this image because there's gonna be tons and tons of different size screens, okay? I'm gonna comment out the provider. I'm not gonna clear the original file provider that I had. We're gonna open up the command line, run the application. We're gonna come back over here. We're gonna remove this image over here. We're gonna come back here and we're going to delete the cache folder. So delete. Coming back to the website over here, reloading. There we have the image again. Let's check the bucket, refresh, and the cache appears here again. So hopefully you have noticed that ImageSharp actually produces logs for you. This is the image that it has loaded, so because we don't actually have the provider, it's incapable of fetching the original image. So it will be using this image over here, and it did manage to produce this cache entry from the local image. And if I come back over here and I give this a refresh, we will see that the image is not modified. If I do a hard refresh, it is getting this image with this cache key. Again, we can attach the debugger to see how it hits the cache. So cloud cache, let's attach. We're gonna go to the image resolver to open read async. Come back over here. Again, I will do a hard refresh. Open read async, we have managed to hit it. And this OBJ, we are reading from the cache right over here. Okay, playing this through. If I come back over here and I say, look, I want width of 600, it's gonna take a little while and we're not gonna hit the open read async method. And if we take a look at the bucket, if I refresh this bucket, there should be a second entry over here, which is responsible for the width of 600. So here you can see the size is a little bit higher. So this is gonna be the width of 600 image right over here, okay? Let's come back to the code, and this will be it. Thank you very much for watching. Hopefully you've enjoyed the 2 videos of how to generate images of different sizes dynamically and also handling caching of that. And basically, you're not doing any work. You're just saying store over here, over there, here are my classes, and then ImageSharp is handling the rest for you. Don't forget, if you enjoyed the video, leave a like and subscribe. If you have any questions, make sure to leave them in the comment section. Don't forget to check out the description, and if you would like the source code for this video as well as my other videos, please come support me on Patreon. Your help will be much appreciated. A very big and special thank you to all of my current Patreon supporters. You help me make these videos. As always, thank you for watching and have a good day.